Pluto's journey through space compels it to rise and fall in its orbit as it intersects with the paths of other celestial bodies, notably when it crosses the trajectory of Neptune in the farthest region of our solar system. Pluto, the intriguing and mysterious dwarf planet, is stirring considerable interest in the realm of astronomy. New findings indicate that Pluto might be on a potential collision course with Neptune, which is causing considerable anxiety among astronomers and space enthusiasts alike. 31 Seconds well-known figures like Neil deGrasse Tyson and Michio Kaku have raised concerns about the possible aftermath of such a cosmic encounter. But what has led Pluto to this possible collision with its neighboring planet? Additionally, what impact could such a celestial crash have on Earth? Come along as we delve into how Pluto's path crosses Neptune's and why this orbital oddity is unsettling the scientific community. Initially classified as a planet, Pluto was later redefined as a dwarf planet due to its irregular orbit. However, despite this reclassification, Pluto still captivates the imaginations of astronomers and space lovers alike. Recently, experts such as Neil deGrasse Tyson and Michio Kaku have voiced concerns over Pluto's orbital path, which could bring it dangerously close to Neptune. This close alignment suggests that these two giant celestial bodies might interact in ways that could have significant consequences for Earth. 1 minute and 4 seconds. Pluto's orbit is unlike that of other planets in our solar system, elongated and unpredictable. Since its discovery in 1930, Pluto has not completed a single full orbit around the Sun, which only adds to its allure. Unlike the more circular orbits of the planets, Pluto's elliptical path stands out as a defining characteristic of our solar system structure. Another captivating feature is the tilt of Pluto's orbit, about 17 degrees from the plane of the ecliptic, which is sharper than that of any of the main planets. This combination of an inclined and stretched orbit adds layers of complexity to Pluto's motion around the Sun. 2 minutes and 10 seconds. One particularly fascinating aspect of Pluto's path is its periodic interaction with Neptune's orbit. For roughly 20 years in each cycle, Pluto's orbit brings it closer to the Sun than Neptune's, an occurrence that defies expectations due to the two planets' otherwise distinct positions. Notably, Pluto's orbit is not circular but shaped more like an oval, which causes significant fluctuations in its distance from the Sun. At its nearest point, Pluto is about 30 astronomical units, AU, away from the Sun, but at its farthest, it stretches out to more than 49 Australian dollars, double Neptune's distance. Pluto's orbit is also tilted at a key angle relative to the orbits of other major planets, further complicating its movements and interactions, particularly with Neptune. When Pluto and Neptune align in their orbits, their gravitational forces alter each other's paths. This intricate relationship underscores the interconnected nature of celestial bodies, with each one exerting gravitational influence that shapes the other's trajectories. 3 minutes and 17 seconds. In recent years, advancements in observational technology have allowed astronomers to track Pluto's movement with remarkable accuracy, offering a deeper understanding of its orbital mechanics and the potential effects on the stability of the outer solar system. Although a direct collision between Pluto and Neptune remains unlikely, the possibility still exists, fueling increased interest and concern among astronomers. Despite its diminutive size and distant location, Pluto continues to capture the attention of researchers and the public alike. 3 minutes and 49 seconds. So why hasn't Pluto collided with Neptune? The key lies in the gravitational interactions between the two bodies. When astronomers first studied Pluto's orbit, they were perplexed by its erratic behavior. Unlike most planets that stay within a consistent plane of orbit, the ecliptic, Pluto's orbit deviates sharply, adding another layer of mystery. The real puzzle came when scientists realized that Pluto's orbit intersects Neptune's. Yet, despite this unusual overlap, Pluto's orbit remains stable. This phenomenon speaks to the intricate mechanics of space and the difficulty of predicting celestial paths. 4 minutes and 22 seconds. Understanding the gravitational interplay between Pluto, Neptune, and the Sun presents a significant challenge for scientists. Predicting these interactions is akin to determining future positions based on initial conditions and gravitational forces. For Pluto, the interaction between its orbit, Neptune's orbit, and the Sun's gravitational pull creates a delicate system that keeps its path stable. Terms like precession, libration, and VSOP variations help astronomers understand these complex dynamics. These concepts are vital for ensuring the stability of planetary orbits. When Pluto crosses Neptune's orbit, it is still about 90 degrees away from Neptune, which prevents any direct collisions. The process of libration ensures that Pluto stays safely on its orbit, even as it approaches Neptune. 5 minutes and 33 seconds VSOP variations, named after researchers like Vaughan and Pacer, explain why Pluto's orbit might seem irregular but remains predictable over time. Even though the cosmos may seem chaotic, the forces at work tend to stabilize planetary orbits, reducing the likelihood of a collision between Pluto and Neptune. This delicate balance highlights the sensitivity of celestial orbits to their starting positions. Even small shifts in a planet's velocity or position can cause significant changes over time. Through advanced computational simulations, astronomers have modeled Pluto's orbital movement, observing how minute variations in variables can dramatically alter its course. In the late 20th century, these simulations revealed that while Pluto's orbit might appear stable, it can still be subject to chaotic fluctuations. Even tiny differences in Pluto's starting position or velocity can lead to notable changes over time. However, Pluto's orbit has remained stable for billions of years, suggesting that despite its apparent irregularities, it follows a discernible pattern. 10 minutes and 20 seconds. Both Tyson and Kaku agree that monitoring a potential Pluto-Neptune collision offers a unique opportunity to advance our understanding of the universe. In particular, such an event could provide valuable data for string theory, which models the universe as a series of vibrating strings. Although the immediate effects of a Pluto-Neptune collision on Earth would be negligible due to the vast distance, the scientific benefits would be far-reaching, enhancing our understanding of theoretical physics and the nature of the cosmos. As researchers continue to study the gravitational influences exerted by neighboring planets like Neptune, the ever-changing nature of space becomes increasingly apparent. However, space remains full of mysteries. The three-body problem, where multiple celestial bodies exert gravitational forces on each other, is just one of the many challenges astronomers are trying to solve. 11 minutes and 54 seconds. Researchers are closely monitoring these systems to better understand how celestial bodies interact and how their paths can change. In addition to planetary interactions, rogue planets, celestial bodies that no longer orbit a star, can drift through interstellar space. These planets, once part of a solar system, can travel vast distances and occasionally collide with other star systems. 12 minutes and 57 seconds. These ancient impacts serve as a powerful reminder of how gravitational forces from larger bodies can drastically alter the orbits and trajectories of smaller celestial objects. 13 minutes and 56 seconds. In conclusion, just as Pluto's eccentric orbit raises questions about a future collision with Neptune, the historical impacts of cosmic forces remind us of the dynamic and evolving nature of space. The delicate balance of gravitational forces governing planetary systems continues to be a central focus of research, helping us understand how our solar system, and the cosmos at large, has evolved and will continue to change over time. Despite the small chance of a direct impact, the ongoing study of Pluto, Neptune, and their interactions will continue to enhance our knowledge of the forces that shape the universe. By monitoring these interactions, astronomers are laying the groundwork for future discoveries, ensuring that we remain vigilant in our exploration of space. As scientists continue analyzing Pluto's trajectory, new simulations suggest that gravitational perturbations from other celestial bodies, such as Jupiter and Saturn, could have long-term effects on Pluto's orbit. These subtle forces, though seemingly insignificant over short time spans, might gradually alter Pluto's path in ways that astronomers are only beginning to understand. One intriguing hypothesis suggests that Pluto's interactions with Neptune are not random but part of a complex gravitational dance spanning millions of years. Researchers speculate that a hidden resonance, a delicate balance of forces, may be keeping Pluto's orbit from spiraling into chaos. This raises the question, could another force be influencing Pluto's movements, one that we have yet to identify? 17 minutes and 10 seconds. The idea of an unseen force affecting Pluto's orbit leads to speculation about the presence of a distant, undiscovered planet, often referred to as Planet 9. Some astronomers believe that a massive, unseen world lurking beyond Neptune could be subtly altering the orbits of Kuiper belt objects, including Pluto. If this is true, then Pluto's orbital oddities might be a clue to locating this mysterious planet. To test this theory, researchers are refining their models and conducting deep space surveys, searching for faint signs of a distant planetary body. If Planet 9 exists, its gravitational pull could explain not just Pluto's orbital quirks but also the peculiar movements of other distant objects in the solar system. 18 minutes and 45 seconds. Meanwhile, Pluto's mysterious geology continues to captivate scientists. NASA's New Horizons mission provided breathtaking images of Pluto's icy plains, towering mountains, and possible subsurface ocean. If Pluto truly has liquid water beneath its frozen surface, then its future interactions with Neptune could have even more dramatic consequences than previously imagined. Some scientists suggest that if Pluto were to experience a powerful gravitational disturbance, perhaps from a near collision with Neptune, it could trigger geologic activity within the dwarf planet. This could result in surface fractures, cryovolcanic eruptions, or even the exposure of an ancient ocean, revealing clues about Pluto's history and potential habitability. 20 minutes and 12 seconds. The question remains, what does Pluto's future hold? If its orbit remains stable, it may continue its isolated existence on the fringes of the solar system. But if unforeseen gravitational influences push it toward Neptune, the consequences could be more dramatic than expected. The discovery of new celestial mechanics and interactions in the outer solar system has already reshaped our understanding of planetary evolution. Pluto, once thought to be a mere frozen relic, has proven to be a dynamic world with mysteries still waiting to be uncovered. As astronomers refine their models and technology advances, the search for answers will continue. Will Pluto remain in its precarious yet stable orbit? Or will an unseen force, whether Neptune, Planet 9, or an as-yet undiscovered cosmic influence, change its fate forever? Only time, and the relentless pursuit of knowledge, will tell. The search for answers about Pluto's fate takes a new turn as astronomers begin re-examining ancient celestial records. Some of the oldest star charts, dating back to early civilizations, describe unusual movements in the night sky, erratic paths that some now suspect could be linked to distant planetary bodies yet to be discovered. Could historical observations hold clues about Pluto's past interactions with Neptune or even an unseen force lurking in the outer reaches of the solar system? As researchers sift through archival data, modern technology is also pushing the boundaries of discovery. The James Webb Space Telescope, JWST, has been directed toward the Kuiper Belt, capturing unprecedented images of Pluto's surface and its 5 known moons, Charon, Styx, Nix, Kerberos, and Hydra. Unexpectedly, the latest images reveal faint distortions in the background stars, suggesting that a massive, unseen gravitational force may be bending light in the vicinity. 22 minutes and 15 seconds. This revelation sparks renewed speculation about the elusive Planet 9 and whether it is playing a role in Pluto's orbital dance. If such a planet exists, it could be the missing link explaining why Pluto and Neptune have maintained their intricate gravitational relationship for millennia without colliding. The discovery of a 9th planet could revolutionize our understanding of the solar system's architecture, shifting our perspective on planetary formation and the hidden forces that govern celestial mechanics. While theories about Planet 9 grow, another groundbreaking discovery emerges. Pluto's largest moon, Charon, is exhibiting strange rotational behavior. Long thought to be tidally locked to Pluto, new data suggests that Charon may be experiencing irregular wobbles, possibly due to external gravitational influences. If Charon's motion is being affected by a distant, unseen force, it could provide further evidence that something massive is lurking beyond the known boundaries of the solar system. 23 minutes and 40 seconds. The potential consequences of a shifting Pluto-Neptune relationship remain a hot topic of debate. Some astronomers believe that even if a collision never occurs, gravitational perturbations could still cause ripple effects throughout the Kuiper Belt. This could destabilize the orbits of other icy bodies, sending a cascade of comets and asteroids toward the inner solar system. If even a fraction of these objects were to cross Earth's path, it could lead to an era of increased meteor impacts, much like the late heavy bombardment that shaped our planet billions of years ago. This raises an even more urgent question. Could Pluto's orbital instability indirectly endanger Earth? The scientific community is divided, with some arguing that such a scenario remains highly improbable, while others urge caution. Advanced simulations are being run, factoring in gravitational influences from Jupiter, Saturn, and even the Sun's galactic motion, in an attempt to predict how the next few million years might unfold. 25 minutes and 10 seconds. Meanwhile, deep space missions are being proposed to place probes in strategic locations within the Kuiper Belt. These robotic explorers would monitor Pluto's motion in real time, mapping subtle variations in its orbit and scanning the surrounding space for gravitational anomalies. If successful, these missions